Hello again, welcome to the midterm review, this time for chapter 17. And again, I'm going to reference you to the Word document that was posted to week 4 as a study guide that has the main points for each chapter that you need to be familiar with. And so in chapter 17, there's several of them regarding activity-based costing, difference between that and traditional cost systems, and we'll go through a problem here in just a moment that highlights those differences. The use of cost pools and cost drivers, and again our problem is going to be going through some examples of those. And then understanding the difference between value-added and non-value-added activities, how they affect product cost, and then understanding the concept of just-in-time manufacturing and what needs to be present for it to work effectively. So our video example here is the decision toolkit problem, which you can find on page 914. And of course the problem along with the solution is presented there, but I thought it still might be a good idea for us to walk through this problem step by step to hopefully gain you a better understanding of what's going on here. So the first thing it asked you for was the overhead cost and the total cost for these treadmills. And using the traditional method, you were given some information regarding direct materials, direct labor of 820 hours costing $18 per hour, and then an overhead applied rate under the traditional method. We're using a single rate here of 300%. So in figuring the overhead cost using the traditional method, what we needed to do, basing it on direct labor cost, is first of all figure the direct labor cost, which again was the 820 times 18 or 14,760, multiply that times the overhead rate that we were given of 300%, which is basically the same as multiplying it times 3, and that gives us an overhead assigned cost of $44,280. So that means our total cost of producing these treadmills, 150 of them, is $114,540. So when we divide that cost, that total, by the number of treadmills, we get a cost per unit of $763.60 under the traditional method. Now, moving to the activity-based costing, and here in part B, for this you were given a whole bunch of cost drivers, overhead cost pools. There were 6 of them in total: engineering design, machine setup, machining, assembly, packaging and shipping, and building occupancy. So these are all pools for which there's going to be some basis for overhead assignment. Now, you were also given that the share of these pools that was going to be assigned to the treadmills was a certain number of the activity for each pool. So starting with engineering design, they gave us that 330 hours of engineering design was devoted to the treadmills at $30 an hour. That gives $9,900 of engineering design overhead charges. The machine setup, they gave us that there would be 22 setups involved with this production run of 150 treadmills, each costing $200. So that gives us a total machine setup cost of $4,400. Machining, they gave that there would be 732 hours of machining associated with this production run, and each hour costs $25. 732 times 25 gives 18,300. And with assembly, 1,500 hours of assembly, each at $8. So 8 times 1,500 is 12,000. And then packaging and shipping, and that's, I want to make sure I give this right here. And that too is based on hours. And jumping back up to assembly, that was based on $8 per sub-assembly. So I may have misspoken a second ago on that. So packaging and shipping is based on packaging and shipping hours again. So 152 hours times $15 an hour gives $22.80. Building occupancy is based on machine hours and a charge of $6 per hour, and a total of 732 hours. So you can see that matches the machining hours that were charged above. But this has to do with building occupancy. So that cost comes out to $43.92. We add all 6 of those overhead items together, we get $51,272 as our total overhead cost. Now we add that to the direct materials and the direct labor, which are the same as they were in the traditional example. 55,000 of direct materials, 14,760 of direct labor. That gives us a total cost of $121,532, which you'll notice is different than what was computed under the traditional method, because the overhead cost now is a little bit higher, and we divide that by the number of treadmills to get a cost per unit of 810.21. So the final part of the problem is asking, well, what should be the recommended way to go in assigning overhead in the future? And for this company, the way to go would be using the ABC method. You're getting a more precise answer. You can see that there is a pretty significant difference in the cost per unit using ABC versus using traditional. So it would help the company in determining the right price to set for the product in order to maximize its profits. So with that, that wraps up the Chapter 17 review. See you for Chapter 18.